NEC Section 250.28 addresses the bonding requirements when conductors from different electrical systems are installed within the same raceway or enclosure. The fundamental principle is that all metallic parts within that shared raceway or enclosure must be bonded together to establish a common ground. This requirement applies irrespective of the voltage levels of the individual systems involved. In simpler terms, whether you have a 120-volt circuit and a 277-volt circuit or any other combination of voltages from different panels, if they are present in the same box or raceway, the metallic components of those systems must be interconnected and bonded. The rationale behind this rule is to ensure electrical safety and to minimize the risk of electrical shock or fire hazards. Bonding creates a low impedance path for fault currents to flow back to the source, facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses. This rapid clearing of faults helps to prevent dangerous voltage build-up on metallic parts and reduces the duration of exposure to hazardous conditions. The specific metallic parts that need to be bonded include, but are not limited to, metallic raceways, metallic enclosures, metal boxes, metal conduits, and any other metallic components that are likely to become energized in the event of a fault. The bonding connection must be made using appropriate bonding jumpers or conductors that are sized according to the requirements of the NEC. It is crucial to consult the relevant tables and sections of the NEC to determine the correct size of bonding conductors based on the size of the overcurrent protective devices protecting the circuits. Furthermore, the bonding connections must be made in a reliable and mechanically sound manner, using approved connectors and techniques. The connections should be free from corrosion and should be able to withstand the stresses and strains associated with normal operation and potential fault conditions. It's important to emphasize that the requirement for bonding applies even if the different voltage systems are derived from separate sources, such as different transformers or generators. The key factor is the presence of conductors from multiple systems within the same raceway or enclosure. Moreover, the requirement for bonding is not limited to power circuits. It also applies to control circuits, signaling circuits, and other types of electrical systems. In summary, NEC Section 250.28 provides a clear and unambiguous requirement for bonding metallic parts when conductors of different systems are installed in the same raceway or enclosure. This requirement is essential for electrical safety and helps to minimize the risk of electrical shock or fire hazards. Ignoring this requirement can have serious consequences and can violate applicable electrical codes and regulations. When working with electrical systems, it is always prudent to consult the NEC and other relevant standards to ensure compliance with all applicable requirements. Firstly, understand the basic principle of bonding in electrical systems. Bonding refers to the intentional connection of metallic parts that are not intended to carry current under normal conditions. The purpose of bonding is to create a low impedance path for fault currents to flow back to the source, thereby facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses. Secondly, identify the specific metallic parts that need to be bonded. These typically include metallic raceways, metallic enclosures, metal boxes, metal conduits, and any other metallic components that are likely to become energized in the event of a fault. Thirdly, determine the appropriate size of bonding conductors or jumpers. The NEC provides tables and guidelines for sizing bonding conductors based on the size of the overcurrent protective devices protecting the circuits. It is crucial to consult these tables and guidelines to ensure that the bonding conductors are adequately sized to carry the expected fault currents. Fourthly, make the bonding connections in a reliable and mechanically sound manner. Use approved connectors and techniques to ensure that the connections are free from corrosion and are able to withstand the stresses and strains associated with normal operation and potential fault conditions. Fifthly, verify the integrity of the bonding connections. Use appropriate testing equipment to measure the impedance of the bonding path and to ensure that it is within acceptable limits. A high impedance bonding path can impede the flow of fault currents and can compromise the effectiveness of the grounding system. Sixthly, document the bonding connections. Maintain records of the bonding connections, including the location of the connections, the size of the bonding conductors, and the results of any testing or inspections. This documentation can be helpful for future troubleshooting and maintenance activities. Seventhly, understand the specific requirements of NEC Section 250.28. A. This section addresses the bonding requirements when conductors of different systems are installed in the same raceway or enclosure. The key takeaway is that all metallic parts within that shared raceway or enclosure must be bonded together to establish a common ground, regardless of the voltage levels of the individual systems involved. Eighthly, apply the bonding requirements consistently across all electrical systems. The principles of bonding are not limited to power circuits. They also apply to control circuits, signaling circuits, and other types of electrical systems. Ninthly, stay up to date with the latest revisions of the NEC. The NEC is updated every 3 years, and it is important to stay informed about any changes or additions to the bonding requirements. Tenthly, seek guidance from qualified electrical professionals. If you have any questions or concerns about bonding requirements, consult with a licensed electrician or other qualified electrical professional. They can provide expert advice and ensure that your electrical systems are properly bonded and grounded. Consider a scenario where you have a 120 volts lighting circuit and a 208 volts motor circuit running in the same metal conduit. Both circuits originate from different panels. According to NEC 250.28, A. The metal conduit itself must be bonded to the grounding electrode system. This means that the conduit must be connected to a grounding conductor that runs back to the main grounding electrode. Additionally, any metal boxes or enclosures that the conduit terminates in must also be bonded to the grounding system. The bonding connection ensures that if a fault occurs in either the 120 volts or the 208 volts circuit, the fault current will have a lower impedance path to return to the source. This will cause the circuit breaker or fuse protecting the faulted circuit to trip, quickly disconnecting the power and preventing a dangerous voltage from appearing on the metal conduit or enclosures. Without proper bonding, a fault could cause the metal conduit to become energized, posing a significant shock hazard to anyone who comes into contact with it. For example, if someone were to touch the energized conduit while standing on a grounded surface, they could receive a severe electrical shock. Therefore, it is crucial to follow the bonding requirements of NEC 250.28 to ensure the safety of people and property. The size of the bonding conductor must be appropriate for the size of the overcurrent protective device protecting the circuit. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent device. The bonding conductor must be installed in a manner that provides a reliable and permanent connection. The connection must be made using approved connectors and methods. The bonding conductor must be protected from physical damage. The bonding conductor must be readily accessible for inspection and testing. It is important to note that bonding is not the same as grounding, although the two terms are often used interchangeably. Grounding refers to the connection of an electrical system to the earth. Bonding refers to the connection of metallic parts that are not intended to carry current under normal conditions. Both grounding and bonding are essential for electrical safety. Grounding provides a path for fault currents to flow back to the source, while bonding ensures that all metallic parts are at the same potential, reducing the risk of shock. In addition to NEC 250.28, A. There are other NEC sections that address bonding requirements. For example, NEC 250.92 addresses the bonding of service equipment, and NEC 250.96 addresses the bonding of separately derived systems. It is important to consult all applicable NEC sections to ensure that electrical systems are properly bonded and grounded. Proper bonding and grounding are essential for electrical safety. They help to protect people and property from electrical shock and fire hazards. By following the requirements of the NEC, electrical professionals can ensure that electrical systems are installed and maintained in a safe and reliable manner.